Banana for scale. This is a huge metal blob. My client inherited it from a family member, and not knowing what it was, the blob was almost thrown away. Thankfully, it was brought to my shop instead. Can I uncover its secrets? Is it real gold? And if it is, how much gold is actually in there?
It's really heavy.
533.3 grams heavy. Now, the first step in my investigation is to cut a small sliver off of this blob. I'm going to use my gold tester to find out just exactly what it's made of. Using an acid solution, this machine will tell me whether the metal is not gold, 10 karat, 14 karat, 18, etc. Dipping the sliver down into the acid well, I can see that it's very clearly reading 10 karat. But just to make sure, I want to check my solution with this 18 karat gold ring. Bingo. 10 karat gold is 41.7% pure. In other words, 41.7% of this blob is pure gold, which means 58.3% is not. It's other metals, and who knows what else. The mission: extract the pure gold, using chemistry, literal gold refining. But there's just one problem. I'm not a chemist. In fact, I've never even taken a chemistry class. Math tells me that I should be able to extract 222 grams of pure gold.
So I think the 222 grams is the best case scenario. I'm actually expecting a lot less than that. In fact, it looks like the blob maybe wasn't even completely melted all the way through. You can see it was kind of fragmented here, the way that it's folded on top of itself. It just kind of looks weird. So I'm really interested to see what the final total is. So let's go ahead and melt this down and start refining.
Off to a great start. My largest crucible and the blob won't even fit inside. Nothing a little fire can't fix. The blob has imploded down into the crucible, and it's taking an extreme amount of heat to get it into the liquid state. You can see just how much sludge and flux has built up around this beautiful golden sun. I attempted to pour some out of the crucible. It didn't go super well, but it's already incredibly satisfying to see just how much junk has separated from the gold. Next, I'll be doing some water casting. Now, some jewelers use this method to create some really cool looking organic shapes. Basically, all you do is liquefy your metal and pour it over water. I didn't know it at the time, but I was actually making a mistake here. You see, I don't want this beautiful looking mountain that sort of looks like an erupting volcano. I actually wanted a bunch of small individual pieces. And there definitely are some there, but the majority of the gold all got stuck together, primarily due to the fact that the beaker was too small. There wasn't enough time for the gold to cool properly before it just adhered to itself. It really was just a rookie mistake. I mean, it kind of looks cool, I guess. I don't know. Let's turn it and see this. Oh my. The blob has a face. This is the face of the blob. This is the personality of the blob manifesting itself. It's alive. And now he's dead. But never dead. Just melted into a new shape. Gone, but never forgotten. Trying the water casting again, this time in a 5-gallon bucket. Yes. These were the flakes I was looking for. This is so much better, and you can see a lot of the darker flux actually separated from the gold as well, which I'm super happy about. I then took all my gold nuggets and boiled them in distilled water. Using a stirring rod, I really wanted to break apart any of the flux and dirt and anything else that was in there that wasn't part of the original alloy itself. You can just see how dirty this beaker is. I also used this filter, which has a filter paper inside, and it did a perfect job at capturing just a lot of that junk. But there's also a lot of gold in there, so I don't want to throw it away. I want to rinse out my filter and my filter paper. I'm going to keep this in a separate beaker, and it's just really fun to see how much the gold is already getting cleaned up. I'm going to deal with this dirtier beaker later. I have a plan on how I'm going to get that gold out of there. Pouring off the cleaner gold into a filter, there's still some bigger black pieces I need to hand pick out, but the bigger problem is this dirty beaker that has a lot of really small pieces of gold. I was really hoping this black stuff would just be water soluble and just dissolve on its own, but it was being pretty stubborn, so I came up with the idea of just pouring it into this filter paper, folding it up. I'm going to put it in my crucible, melt the whole thing down, and separate the gold from it that way. And that worked perfectly. I'm super happy that I took the time to get every little tiny piece of gold that was left over, because when you add it all up, it's 17.5 grams. Very much worth it. I'm gonna add this little guy back to the group and just look at how clean it looks. I'm already so happy. It's starting to look like gold, which is pretty fun. Next, I wanna throw this on the scale just to see how much junk we got rid of and how much metal is left over. So we are at 514.6 grams. The blob has already slimmed down by 18.7 grams, and we have this beautiful flake left over ready to dissolve. It's time for the chemistry.
Warning, this video contains methods and procedures that are extremely dangerous. I'll be handling acids that are incredibly corrosive, toxic fumes are present, as in they can kill you. And that's bad. Please do not try this at home.
I start by adding 3 parts hydrochloric acid to my metal. Next comes 1 part nitric acid, and the reaction is swift. This is aqua regia, a liquid so corrosive it can literally dissolve gold, copper, silver, zinc. The reaction is giving off some beautiful orange fumes, and these are definitely the ones I don't want to inhale, which is why I'm doing this entire project under a fully vented fume hood. The orange fumes are an indicator that the reaction is still going on, so I let this boil for multiple hours until the orange completely dissipated. This is the exact moment that reality started to sink in. I have been dissolving this metal for hours, and look how much is undissolved. That's when I truly realized that this wasn't going to be an easy project, this wasn't going to be quick, and I was in it for the long haul. Mixing together a fresh batch of aqua regia, I'm going to move my metal over to a hotter burn plate, and I figured the increase in heat would make the reaction go quicker, and boy was I right. It's very necessary to make sure that the nitric acid is completely boiled out of the solution, and this takes hours, but it's something that is going to be imperative for a later step in this video. Pouring off my second batch of liquid metal, I can see that the reaction did a lot better this time, and a lot more material was dissolved. There's just a little bit left. I'm going to do this one last time. Using a stir rod and swirling around the beaker and not having much resistance was truly a wonderful feeling. All of the metal has been dissolved, and it's time to move to the next step, which is separating the liquid from the silver chloride. And I do this by pouring everything over a filter again. As you know, I had to dissolve all this metal in multiple attempts, so I have lots of different beakers filled with dissolved metal, and I will pour them all individually through this filter, capturing as much silver chloride as I can. Now there's actually a way to save all this silver chloride and refine it and turn it back into pure silver, but that's going to be maybe for another video. We're only really concerned about gold in this video. And now that all the liquid has been filtered, it's time to add some sodium metabisulfite to this liquid. And this is probably the coolest part of the project. The sodium metabisulfite literally precipitates the gold out of the solution. It's really wild. It's hard to see on this step just due to how dark and green the solution is, but stick around. It's gonna look really cool later. This is exactly what we're looking for. This is gold. though not a medium of gold I've ever seen or used before. After precipitating the gold out of all my different beakers, I decided to combine all of the gold mud into one place, which was really refreshing, honestly. After dealing with so many different beakers, I used a spray bottle just to make sure I was getting all the last remnants. I was really happy to get to this point in the project. I had sunk so many hours into it and already felt like I was almost done. But my research told me otherwise. You see, in order to achieve a higher purity, I needed to repeat the entire process. I really wanted to quit, but I'm so glad I didn't. Introducing Gold Refining Part 2, the Forbidden Orange Juice. I'm kicking things off with the ever-familiar Aqua Regia, but the reaction, it looks different this time. It has beautiful, deep, and rich orange colors, and the gold mud, well, it put up no fight in dissolving quickly. Pouring it over ice, I give you Forbidden Orange Juice. You can see there was some silver chloride left over, which validates my decision to repeat this refining process. Remember the last time we added sodium metabisulfite and couldn't see our gold precipitating very well? Check this out. I keep adding scoops while the gold collects at the bottom, but there's one really important thing we haven't discussed yet. How do I know when all the gold has been precipitated? Well, there's a test for that called a Stannis test. I mix together hydrochloric acid and pure tin, which creates Stannis chloride. This solution is incredibly sensitive to the presence of gold, and I'll show you how it works. I first take a strip of filter paper and I dip it into my beaker that has the dissolved gold. Then I'll add a drop or two of the Stannis chloride and watch for a reaction. If it turns black, you know there is still gold in your solution. So in this case, there is, and I need to keep adding sodium metabisulfite. You want to be careful to not add too much of this, so I kind of decided to stop here for the night, let it collect at the bottom, and just try again the next morning with my test. The next morning, I discovered everything had settled to the bottom. I thought to myself, all the gold surely has to be out. But let's see what the test says. There's still gold in my solution? So I went ahead and added some more hefty scoops and turned up the heat a bit, and waited for many hours for things to calm down. Admittedly, things are looking very clear now, and dipping my filter paper into the beaker, it emerged colorless, which had me super optimistic. And the Stannis test? It confirmed no more gold remained in the solution. Another happy milestone. I poured off the excess liquid and was left with my pure gold dirt, which I then cleaned by boiling it in distilled water. I gave the gold a few different distilled water baths, and one bath in hydrochloric acid. This seemed to do a great job at purifying the gold even further before melting. I left the beaker on a hot plate until all the distilled water dried up. And just look at this gold. The color is absolutely incredible. I've truly never seen anything like it in all my years as a goldsmith. This gold is only worthy of a brand new, freshly glazed crucible. Igniting my melting torch, it's time to return this gold to solid metal. Poured the gold into a bar shape, and while it looked nice, it just didn't feel right. This gold came to me as a blob, and it only felt right to return it to a blob. A pure 24 karat blob. The mission is complete. I successfully extracted gold. But there are two burning questions left to be answered. First, how much does it actually weigh? How close did I get to my initial calculation of 222 grams? The final weight? 213.2 grams, only 9 grams shy of my initial estimate. This definitely exceeded my expectations. The second question is just how pure is it? Did I achieve 24 karat? So I sent it to a refinery and I got my answer. It came back as 99% pure. Official Gold Bullion has a purity stamp of 999.9. And I was really hoping to get a purity rating with at least 3 9s, but I discovered afterward that this refiner doesn't grade that high. So while I'll never know for certain, I do take comfort in knowing that 23 karat gold is 95.8% pure, and I'm well above that. It's safe to say that I truly did extract 24 karat gold. This was by far the most ambitious gold project I've ever done, as well as the largest YouTube video I've ever done. If you enjoyed it, please consider subscribing to the channel. If you want to see me make a precious ring out of gold like this, you'll definitely want to check out this video. Thanks for watching.